This video will look at using a graphic calculator to solve a difficult equation. There is an example in the text and I'm going to follow that one. We must begin by getting up a new document of the appropriate type. This will mean a graph, and we will enter the first of the two graphs, which is x to the power 5. Be careful when you're using the power button to exit the index before you continue entering, otherwise subsequent entries will be put in the index. So we have minus x squared and then minus 2. Press enter and you will get the graph. We've been quite lucky here because the graph has appeared on the screen. It's quite common for students to get very flustered when they enter a new graph and press enter and they see nothing. Often the reason is because their viewing window is set wrong, and you need to be thoroughly familiar with how you alter the viewing window in order to see the parts of the graph that you really want. So window zoom, and you've got a variety of things that you can do: set boxes, zoom in, zoom out, or even set the viewing window. I'll exit from that. You may also not be aware of the fact that you can actually on screen edit the graph labels. And if I change that to -2 and enter it, we immediately get a new viewing window. So that can be helpful as well. So that's our first function entered. What we now need to do is enter a second function, which you can do just by pressing the tab key. The second function is 1 divided by, and you must use brackets here, x plus 1, and we do not need to close brackets, but you do need to exit from the bracket, very much like you needed to exit from the index in the previous function. Okay, and we complete this with +5 and enter. Well, we can see actually quite well, without fiddling further with the viewing window, that we have two intersections here. And these two intersections represent the solution to the equation where that function is equal to that function. Think about this for a bit, because it's important that you have that clear in your mind, why there is a connection between the feature on the graph, the intersection points on the graph, and the solution of the equation. How do you set about finding these intersection points? Well, we have an analyze graph facility here, and there are a variety of things you can do with it. Our particular point of interest here is intersection. The Texas calculators can only find intersections one at a time, and what you get asked to do is set up a range in which the calculator is looking for the intersection. So get this barrier here using the arrow key or the touchpad so that it's to the left, click or enter, and it will find the intersection. You will see that we don't have a terribly accurate answer here, and we were rather looking for a considerably more accuracy. Now, there is a tendency to think that this must be something to do with the document setting, but the correct way to do this actually is in the menu, and you have a settings feature down here which is different from the main document settings, and we have currently got it set to float 3. That means scientific notation with 3 significant figures. We want 4 decimal places, so we will need to float 5, and here we have the answer that we were looking for. Moving on to how we might solve the same problem using a Casio instrument, I will begin with the main menu screen, and as we did with the Texas, we will use the graph module. I have actually entered the 2 equations to save a bit of time. Once you've done that, all you need to do is F6 draw, and you will get a picture of the graphs very similarly to the way in which it happened on the Texas instrument. We're using here the standard zoom. Viewing windows can be altered very much as they are on the Texas, either manually using a view window, or F2 zoom allows you to change things so that you actually get to look at what you are trying to look at. Now, I have deliberately here messed up the viewing window. Can you see that you might be quite bothered in an examination if you entered this and you saw this picture here and you're looking for intersections? So you do need to practice quite thoroughly and well how you actually change the viewing window so that you see what you need to see. I'm going back to the standard viewing window. I will exit from that and go back to draw, and there we are back again with a useful picture. So we can see that there are two answers here. The question only asks for the positive answer, so we're after this one up here. The Casio instrument uses a facility called GSolve, which again you should be thoroughly familiar with. It offers you a variety of things that you can look for, features on graphs, and I suggest you practice with these so that, again, when you're in an examination or a test or something, it comes to you straight away what you're supposed to do. We're after intersect here, which is F5, and the calculator will immediately go for intersection points on the graphs. What we need to do now is the calculator does actually deal with multiple intersection points, unlike the Texas instruments that requires you to enter viewing areas and calculate them separately. We've got the one that we didn't actually want here, but you just need to use the right arrow and the cursor will switch to the solution that we need. And here we have our solution 1.5813.